Today is the first class of our semester. So in this hour, I'm going to introduce what this class is all about, and then I'm going to introduce some idea of ultrasonic engineering or ultrasonic testing. So my name is No-Hyo Kim in mechatronic engineering. My room is a D204 in this engineering building number 1. So I know you have many questions and some remarks about my lecture I did or I will do. Then just do not hesitate to come to me and then ask about what you don't know or what you have in your class. So I'm going to briefly introduce the main idea of ultrasonic non-destructive evaluation. So it's going to cover first of all the basic theory of ultrasonic or acoustic theory, and then mainly it's going to focus on some non-destructive testing using ultrasound. So you will learn about, first of all, the basic theory of acoustics, and then secondly, you will learn about some basic ultrasonic equipments, including ultrasonic sensors and ultrasonic equipment like a ultrasonic pulsar and receiver. And finally, in the last part of this lecture, I will cover some application of ultrasonic engineering specialized in non-destructive testing. And then I'm going to finish this semester lecture by introduce you about mainly application, some fields. Okay, I know you, many of you know about ultrasound, but many of you don't understand or you don't have any background knowledge about ultrasonic non-destructive test. So I'm going to give you some idea about what is non-destructive testing or non-destructive evaluation. Okay? Before I go on, I must give you some procedure or some contents of my lecture. First of all, today I'm gonna give you some overview about ultrasonic non-destructive evaluation or non-destructive test, and then maybe next week or part of this week, I'm gonna cover some basic theory of ultrasonic fundamentals or acoustic waves. So from my experience, this part is the main theoretical part and also the most difficult theoretical part of this lecture. So you must spend many times of yours on this basic theory about acoustics. Okay, so you must understand these acoustic waves first, then you will easily understand the rest of the other parts of this lecture. Okay, so you will do more homeworks on these parts, and then in order to understand the ultrasonic waves, you will also learn about Fourier transforms. This Fourier transform is basis of every electronic signals or signal processing. So you will understand what the Fourier transform is, and then how to use this Fourier transform in ultrasonic signals. And then now I'm going to give you some examples and theories about transmission and reflections of ultrasound. When you send the ultrasound in the material, the ultrasound penetrate and reflect from some barrier that is usually boundary of two different materials. So you will have some reflected or transmitted signals whenever or whatever you do. So you need to understand what kind of reflection and transmission occur during the ultrasonics propagation. And then the rest of my lecture will be about some hardwares, transducers and measurement systems. And then lastly, I'm going to give you some application examples in this final part of my lecture. Okay, so you will learn about some basic theory maybe in the first part of maybe March and April, and then you will learn about some FFT and transmission and reflection signal during maybe May or early May or until mid-May, and then last of my semester will be covered in this field. Okay, I'm gonna give you the definition of NDT. NDT is a abbreviation of non-destructive testing. N stands for the non-destructive, and T means testing. So what is NDT? The NDT is any method that is non-invasive. Non-invasive means you must not break or you must not change, you must not stop the operation, or you must not change any shape or material properties, anything. In order to test or in order to know a material property or dimensions of the system of your interest, something like that. So whatever you do without breaking or without stopping the operation is maybe called non-destructive testing. So the meaning of the NDT is so wide, but we're not going to cover the whole aspects of this NDT area because it's very huge. So we're going to focus our interest on specific field that use ultrasound, which is called ultrasonic non-destructive testing. Okay? Do you understand? All right. Good students. So I'm going to show what kinds of NDT method is now used in industry. Let's take a look at some of them. First of all, visual inspection. Visual inspection is the NDT method that is widely used still in the industry because that is the fast and that is the cheapest one to inspect what defects or what kind of wrong thing is going on in the material. So you need to do all the time, and whenever you do what kind of materials in these slides you're going to use. So visual inspection is just looking at the material with your bare eyes. One of the most frequently used visual inspection is that selecting watermelon in hot summer days. You know, watermelon, right? Subak, watermelon. So what are you doing to select or you choose the well-ripened watermelon? It's a good watermelon. What are you doing? So what do you do when you want to choose the best delicious watermelon? You don't know. right? You don't know when you go to the supermarket to buy watermelon. What do? Right. If you speak English, that's the but it's okay if you can speak in Korean. I'm gonna sometimes use Korean because the audience, your students are all Korean students, but some other classes has a foreign students. At the time, we need to use English all the time, but in this class are all Korean students. So if you want to speak English or if you speak in Korean, it is okay. Right. Tap the watermelon, right? So what do you do by tapping the watermelon? 뭐 하는 거야, 그게? 왜? Why do you tap the watermelon? You wanna hear the sound, right? Sound of the watermelon. So, what do you know? What do you know if you listen the sound of the watermelon? You don't know exactly, but somehow you know, yeah. From your experience, many parents said to you that when you choose the watermelon, you tap the watermelon, and then if the sound is soft or the sound has some kind of special features or special sound. That means you have a good watermelon, right? 그죠? 소리가 좋으면. But you don't know which sound is best. But anyway, you tap the watermelon. That is kind of a visual inspection, or it's also part of acoustic emission test. So, and another thing is that you take a look at first the watermelon, right? Right? By taking look at the shape or the color of the watermelon, that is another way to select the best watermelon, right? That is visual inspection, right? Another thing is when you meet a girlfriend or some boyfriend, it's happening all the time in the time about visual inspection, right? Right? That visual inspection is happening all the time. Okay, another one is, the other thing is, one of the best well-known NDT method is X-ray, right? Once a year, usually, every employees in industry take that kind of exam, X-ray, chest exam, right? To take a look at what kind of what is going on in your lung or heart. Okay, then you usually the employees are taking that X-ray exam every year. So X-ray gives you some simple image about inside of your lung or inside your body or inside your bones, right? So that is the most important NDT method you will experience in everyday life. But that is not our topic of this lecture. Among these many NDT methods, we're going to focus on this the green-shaped topic, ultrasonic method, that use ultrasound to take look at something inside the material. So we want to find some defects, or we want to find some cracks or some voids, or we want to measure some material dimension like depth or thickness or something like that. Then we can use ultrasound to do that kind of job. And also the main application about ultrasound is to measure the distance between A to B, or detect the distance between some object A and B. that is usually used in robotics or some in industry. So we're gonna our whole lecture we're gonna cover only this ultrasonic method, other than other methods. This means it doesn't mean that other NDT method is not as important as ultrasonic method. But ultrasonic method is the most emerging, most fastly developing technique in industry. So X-ray is mostly widely used NDT method, but ultrasound has more and more importance and more development in this NDT field. So after taking this class, you will find the importance of ultrasound applications. Okay. Next is the last slide of the first introductory remarks in this first hour. Why do we do NDT method in industry? So I'm going to briefly explain about it. Purpose of NDT method, including ultrasound. That is the reason you are taking this class, right? You are taking this class to do this kind of one of these or two or three of this in industry. So if you want to do something like flow detection, the flow means some discontinuity or some cracks or some voids. That is the flow. 이건 무슨 결합물 얘기예요. defects. 우리가 앞으로 많이 쓸 말이요. We're going to use a few terminology or a few words related with NDT is defects or flaws, discontinuity, something like that. All this indicates something wrong part you don't understand, you don't want when you manufacture or you machine or something. So the example of these are something like voids, 기공들, 그죠? In Korean, something like a 기공 or bubbles, or the most important things in NDT is cracks, right? Something like that. So this picture shows you a crack occurring in crankshaft rod in an automobile industry. So you will see some kind of crack in the center of the bar. So the main job of ultrasonic testing is to find that cracks in the material of your interest. If you're interested in a crankshaft, something like this. Or if you want to find some voids, that is called defects or flaws or discontinuity. Okay? And also, you can use ultrasound to find where the leaking is taking place in pressure vessel. As you know, last weekend and today, Japanese nuclear power plant has severe problem. Okay, but what they continuously report to the mass media that they are safe, right? You know why they say? The reason is the nuclear power plant is, as you know, is something like this. This is a containment, 경납고. It is very 1 meter thick concrete building to protect this pressure vessel. This called is a reactor. That is most important in the nuclear power plant. So this one is almost 1 meter thickness of concrete. The main reason of this containment, this concrete, is to protect this one. This one is a reactor vessel. This one is made of high strength steel. It's welded around something like this. Something like this. It looks like a capsule. But this one is all welded, so that sometimes if it has some crack on the surface, this radioactive materials is leaking through this crack. So that's going to be the big problem. Not this problem, but this pressure vessel reactor. If this reactor has some small cracks, it's going to be very severe, huge problem. So that sometimes you need to find where or how much the leakage is taking place in this kind of pressure vessel. So in that case, you can use ultrasound to detect or find it could happen, or it could not happen. And also, you can find where the leakage is taking place, the third item. And also where the leak or where the cracks of your interest is taking place, the third item. Then you can use the NDT method to find it. And another major important area of NDT is the dimensional measurement. Okay? If you want to measure my height, okay, without touching me, without any, without doing anything, you can use ultrasound. Let's think about this. If you put ultrasonic sensor on the top of the ceiling, then it sends the ultrasound from the ceiling to my top of head. Then you can measure the distance from ceiling and my head. And then if you subtract the whole height of ceiling from the bottom to the distance from this my head to the ceiling, then you can easily measure my height, right? That is one of the simple example of dimensional measurement. Or if you have some thin coating, usually less than 1 millimeter, if it is coated on mother material, and thickness is so thin, so you cannot take this coating off the surface, then what can you do? You can send ultrasound from the surface, and then you can detect the reflected signal from the top of the coating and the boundary of these two materials. Then you can calculate this thickness of coating. That is one of the example of dimensional measurement using non-destructive testing, usually ultrasound. And another one is the characterization, microstructural characterization. What it means is that you want to measure mechanical property, such as Young's modulus or Poisson's ratio or shear modulus or hardness. That is the most important application field of ultrasound. So if you want to measure Young's modulus or yield strength, you can use a tensile tester, but if you don't want to break the material, the alternative is to use ultrasound. That is our main topic or main purpose of ultrasound testing, ultrasound engineering. Okay, other things are some more difficult part of ultrasonic application, so that you will not learn about this because this one is the advanced level of ultrasound. So if you few of you will learn about this one after entering the graduate school or some more higher level of ultrasound. Okay. So I'm gonna show one of few example of how to measure the material property. Usually, when you say about material property, it includes many things, right? But it is composed of two main part in industry: the physical material property and chemical material property. But usually we are not gonna do anything about chemical property because you all mechanical engineer or mechatronic engineer. So we're gonna have interest in physical properties. In physical properties, there are many. In that physical property, you usually have interest in this mechanical property. In that mechanical property, there are many also. So you have heard about yield strength or toughness and hardness and rigidity and stiffness, right? I know you have heard about this mechanical property. In this mechanical property, let's say the tension or tension tester, or what is the tension or tensile strength or impact, or what is impact and what is creep. I'm not going to cover what it means, but if you want to do some toughness test, let's say, toughness measurement is done by this Charpy tester, something looking like this. If you want to know how hard or how tough the material is, you put the material of your interest in this position. You can put it in the hole, and then you hold it, this hammer, and then release it at some point, and then this hammer is returned to the position and then hit the material, and then it breaks, right? So you can increase this degree until this hammer breaks this material. Then you will know how hard or how tough this material is, right? The more the bigger the angle is, the tougher material is this test specimen is. So this is how to measure how hard or how tough the material is. But all this material is all destructive, right? You must break, you must damage the material you have interest in. So we don't want to do this job, the destructive testing. So another alternative way to do this same job is the non-destructive testing. Okay, so we're going to use ultrasound to test or estimate the toughness of material. That is why we use NDT. Okay. Then this is the main reason to measure material property. Why do you need to measure material property? First of all, this one, if you are engineer, development engineer in a company, suppose that you developed a new material, new advanced material, then you want to know what kind of mechanical property is you want to know, right? Then you want to know Young's modulus, how tough it is, or what kind of other mechanical property is. So in that case, you will need a kind of method to measure material property. And also on a design. When you design a new things, new structure, then in the case that you will also need to understand, you will to measure material property also. But third one is my main point I want to make in this class is safety assurance. What is the safety assurance? As I said before, in this nuclear power plant, you wanna know this vessel is called the reactor is safe or not, right? Under the certain circumstance that has a high pressure gas inside. So you want to know this reactor is safe or not. In that case, you will need to estimate the material property, right? Let's say the Fukushima nuclear power plant was built around the 70s, right? So it's already 40 years of operation, right? 40 years old, so very old, right? In that case, at the first time when it's built in 70s, this material should be safe and right. But after the 40 years of operation, the material is deteriorating. What is deteriorating is weakening. material이 처음에는 다 재료 검사를 했겠지만 40년 후가 되면 it's old. So material property has changed, right? I'm not as young as you, right? So my bones and my skins and my muscles are totally different from yours, right? It's not same. How different? How different yours and mine? It's simply to measure it, right? Some sampling of my tissue and yours, then calculate something. It's the same thing is happening in the industry. But you cannot take any part of a reactor in operation, right? What can I do? What can you do? You can do anything about this one, right? In that case, non-destructive testing, ultrasonic method can be applied to this application, right? All right. That is about safety assurance topic. So NDT deals with all three things, but mainly in this class, we're going to talk about these safety problems because this one is urgent, right? When you have some problems in bolt or some desks, you can throw away or you can buy another thing, right? That can be substituted. But this one cannot be substituted or replaced. So this one is urgent, this one is important. So that's why I colored the third item. I'm going to skip all these three things, and I'm going to skip these all things. And I'm going to just briefly stop by this slide because that includes some important application of ultrasonic test. Ultrasonic test has been used in a medical field, human body. Human body is also not replaced or substituted or cannot be cut or you cannot take any part, small part of human body. So this one is the main application field of ultrasound. And another one is semiconductor field, 반도체. Because Semiconductor deals with very small scale structures. So it's too small. So you cannot see anything, or you cannot handle it with your conventional tensile test or other equipments. So that is useless. Tensile machine is so expensive and huge, but to semiconductor circuits or semiconductor devices, it's useless. So you need to have to use other alternative method like ultrasound. And another one is semiconductor is a sub area of this MEMS. You know what is MEMS about? MEMS is stands for the microelectrical or electric mechanical system. It's basically mechanical system, but it's very small and it has some microelectric devices. So it's called MEMS. Nowadays, this one is growing and growing. It has a huge market in industry. So you will learn, or you must know about MEMS system, right? And also large structure. It's small structure. It's a large structure. What is a large structure? It's the airplane and also a huge building. It's a high rise above 100 stories buildings and the largest structure bridges, something like that. This one also is one good examples about NDT application. So these three all are a little bit different from the subject and a little bit different structures you have learned in other classes. So in these classes you usually about some special structures and special features like very big scale or very small scale or some special like human body. So NDT is all about these applications. This one is one of the example of the thin films. Okay, so I'm going to skip all these things. One of my colleagues working in Berkeley, University of California, Berkeley, named his name is Professor Kuri Yakub. He's Jewish. He published one paper in 2000, the millennium years. He published a paper that's telling about what is emerging NDT. As I said before, NDT methods are huge, right? In that huge application or NDT methods, he pointed out few important and few emerging NDT techniques listed in this slide. So these five are most important NDT method will be used in future generation or in the future industry. So you will be heard about one of these NDT techniques. Yeah, X-ray technique is here, and also laser and thermography technique is also is positioned in the fourth and fifth. But first one, he pointed out the first important NDT technique is ultrasound. So NDT has a huge application, but ultrasound is the most emerging NDT techniques. So this class is about this emerging NDT technique, ultrasound. So okay, I'm gonna introduce more about basic property of ultrasound. Then I'm gonna finish the first time of this lecture. What is ultrasound? What is ultrasound? Ultrasound is the combination of ultra plus sound, right? So it is nothing but sound. It's nothing special. Ultra plus sound, right? So ultrasound is basically sound. So we will learn about sound and acoustics in another terms. So what is ultra? Ultra means the above or the beyond, right? So what is the beyond? This ultrasound is a sound above 20 kilohertz of frequency. If any sound has a frequency of 20 kilohertz, then it's called ultrasound. Okay? So it's nothing special. So we're going to basically learn about the sound theory but that has short wavelengths. What it means is, high frequency means is the short wavelengths. High frequency means this one is a high frequency. High frequency. So what the high frequency means is wavelengths. You will learn about this relationship maybe next time. Short wavelengths. How short? Usually in ultrasonic non-destructive testing, you will use usually 1 megahertz ultrasound is the typical frequency of ultrasound. Then what is related to the short wavelengths is wavelengths in wavelength scale is the 1 millimeter. 1 megahertz ultrasound has 1 millimeter wavelengths. Let's say, so I'm talking few words, right? This, my voice has usually few hundreds of frequency. Let's say 400 or 500. That is the main frequency of my voice. This acoustic, right? Sound. 5 or 400 hertz. That has about few centimeter or sometimes 100 or few meter of wavelengths. But why do we use ultrasound other than sound? Because of these short wavelengths. If you increase 1 megahertz to the 1 gigahertz of ultrasound, sometimes we use 1 gigahertz ultrasound. So then wavelengths in that case decrease to 1 micrometer, because 1/1000th of this wavelength. So usually ultrasound has a wavelength between 1 micrometer to 1 millimeter. So let's say a few hundred micrometers is the typical wavelength of our NDT application. So why do you use this kind of short wavelengths? Because this wavelength means the scales. When you measure the height, your height, what kind of basic scale is? That is a centimeter, right? 스케일은 뭘 의미하냐면요, 기본적인 측정의 단위죠. If you smaller scale of measurement, you can measure more precise measurement, right? 뭐 정확한 잘 측정을 할 수가 있죠. 만약 여러분들이 미크론 단위의 잣대를 가지고 측정하면 미크론 단위의 측정을 할 수가 있죠. 만약 여러분들이 자를 갖고 있는데 눈금자가 1cm다. 그럼 1cm가 your maximum measurement 스케일이 되겠죠. 근데 1m 단위의 눈금이 있다. 그러면 그게 basic 스케일이 되겠죠. That's the basic idea of short wavelength usage in NDT. This dimension, 1 millimeter, 1 micrometer, is the basic size of defect or cracks. 여러분들 세계에서 관심 있는 디펙트라든가 크랙의 사이즈가 대개 이 정도예요. 이거보다 더 가는 거 별로 발견할 일이 없죠? 여러분들 구멍을 찾는데 뭐 이렇게 큰 구멍 찾을 일 있어요? 없죠? The topics, the problems, the flaws you will have in your application will be between this 1 millimeter and 1 millimeter scales. So that's why we use ultrasound. Okay? Yeah. All right. So acoustic wave with high frequency above 20 kilohertz is called ultrasound. These four basic property of ultrasound is the main reason we study ultrasound. Ultrasound is the mainly important, the most important. If you want me to pick one of the most important property of the ultrasound is this one, third one. Ultrasound is able to penetrate everything. That is the main reason to use ultrasound in the application field. Without any harm, like X-ray. X-ray can, in physics world, there are two waves can penetrate everything. X-ray, right? Radioactive radiation wave is another one. But that is very harmful to human body, right? As you can see in the Fukushima nuclear power plant accident. But ultrasound is safe. That is the main reason why the professor kroeatech in Berkeley University pointed out ultrasound is the most important NDT method. So this one is the main reason to use ultrasound. It can penetrate everything: gas, liquid, solid, any solids, any liquid, any gases, it can penetrate. So if you are ultrasound, you can see anything. You can see anything inside the concrete. You can see inside. So if you have ultrasound eyes, you will see the person studying next to our classroom or down this concrete. You will see anything. That is very useful aspect of ultrasound. And also it has a short wavelengths comparing to the regular sound. Regular sound has a few centimeter wavelengths, but it's small. So that it means find out small defect, small thing, small structures in the materials. This is another good things about acoustics. Another one is inaudible. It is inaudible. If it is audible, every time when you generate ultrasound, your ear is so noisy and you cannot work it's very, very well. So, and harmful, but it is not audible. You cannot hear. So that is another good thing about ultrasound, right? And this one is the result of the other things. Why is it not harmful to you human? Acoustic wave and X-ray can penetrate any materials, but the basic difference is this one. So why? X-ray is radioactive electric magnetic wave. So X-ray can change your basic DNA or your basic structure of biostructure. So you can change it because X-ray has a very, very fine, very small wavelengths, and then you can penetrate so that it can change your microscopic biologic structure. That is most harmful reason. But this one, acoustic wave is elastic wave. X-ray is electromagnetic wave. That is the main difference of two waves that can penetrate everything. So ultrasound is called in professional terminology. This one is elastic wave. Ultrasound and X-ray are all wave, right? 다 wave예요. ultrasonic wave, but this one is electro. Totally different. Magnetic. Wave, especially radioactive. Radioactive means it can change. It can change the atoms into the ionic state. So it is elastic wave. 한국말로 탄성파. 탄성, 커지고 작아지고 하는 것 때문에 생기는 거. 이거는 전자기파예요. It's totally different. Okay. That is reason. Why ultrasound? 왜 우리가 ultrasound 쓰느냐는 건 this one is a natural consequence of the former slides I talked about. First of all, this one is safe. This one is the main reason we use ultrasound. And this one is the sensitivity. It can show, it has a short wavelength, 1 millimeter to 1 micrometer. So it can give you some very precise measurement of dimension. And also the transparency. It means it can, as I said before, it can penetrate any material. So if you have ultrasonic eyes, it is all things are transparent. All things are transparent. So that means you can see anything inside the material, right? Something like some sci-fi movie, you can see anything. If you wear the ultrasonic goggles, something like that. Okay, I think this all slides gives you idea and what kind of applications, why we use ultrasound in measurement and evaluation. So I think this one is enough that you can catch an idea of the basic philosophy of this class. Okay, next time I'm gonna do more detail about ultrasonic theories. Okay, right. If you have any questions, no. All right. Okay. Thank you.